In this question, we have another hypothesis test. 30 subjects followed the Weight Watchers diet for a year. Their weight changes are summarized by a mean of negative 6.6 pounds and a standard deviation of 10.8 pounds. Use a significance level of 0.01 to test the claim that the diet has no effect. Our first step will be to write the claim itself. Let's have a look at what's being claimed. Now, it's being claimed that the diet has no effect here in line 3. If it's true that the diet has no effect, that means that the people on that diet should not lose weight. In other words, the change in their weight should be 0. So we can say that our claim will be that the mean is equal to 0. Now again, because we have an equal sign, that means that this will be the null hypothesis. If there is no equal sign, that would have been the alternate hypothesis. Therefore, we labeled this claim with HO, null hypothesis. For our second step, we now write the opposite. Now the opposite of equal to would be not equal to. We still use the symbol mu and the symbol 0. And as we've said earlier, the not equal sign is part of the alternate hypothesis. Now that we've written both hypotheses, let's ask ourselves, is this left tail, right tail, or two tail? Now, if our alternate hypothesis is less than, that means it's left tail. If it's greater than, it's right tail. And if it's not equal to, it's two tail. Therefore, based on the alternate hypothesis we've written, we can say that this test is two tail. Now let's think about the possible outcomes. Now, if our big P value that we calculate is less than or equal to alpha, that means we have strong evidence. Because we have strong evidence, we can reject the null hypothesis. So now imagine if we crossed out the null hypothesis, we would be crossing out the word claim along with it. Therefore, we can say that because of our strong evidence, we can reject the null hypothesis, and in that we would reject the claim. Our other possibility is that the big P is greater than alpha. That means our evidence is not strong. Therefore, we do not reject the null hypothesis, or as we say, fail to reject the null hypothesis. In that case, we would stick to the claim because we can't reject it. And the only reason we can't reject it is because our evidence is not strong enough. Therefore, we would say we are going to keep the claim because we can't reject it. Now, step 4, we calculate our test statistic. Now, because we are doing a calculation based on a mean rather than a population proportion, we'll have a different equation to calculate the test statistic than before. This time, because we are doing a calculation based on a mean, we are going to calculate a value called the t-value. The equation for t-value looks like this. We take x bar minus mu divided by standard deviation divided by square root of n, where x bar is our sample mean, but mu is our claim mean. S will be our standard deviation, and n is the size of the sample. Let's input this information into Excel. We'll first make a label for x bar, another label for mu, another label for standard deviation, and another for n. Now be careful here. When we actually ran this experiment, we found that there was a mean of negative 6.6. That is our x bar, our sample mean. However, mu will be the mu from the claim, and the claim didn't give us a number in the question, but in interpreting the words no effect, we can say that the claim is that the weight loss is 0. This can be found here in the claim we wrote as well, in both the null and the alternate. The standard deviation given to us was 10.8, and the n we'll have to read the question again for. Right at the very beginning, it told us there were 30 subjects. We'll place that as our n. Using that information, we can find the test statistic t. We'll say equals parentheses x bar minus mu. Divide by a second set of parentheses. Now we'll take s divided by square root of n. Now, when you finish this test statistic formula, make sure you close the parentheses twice at the end. We get a test statistic of negative 3.34719. Our fifth step is calculating the big P. And once again, the formulas we use when we do calculations for means will be different from what we're used to for population proportions. To calculate the big P on the left tail, we would take t dot dist, then parentheses. First we enter the test statistic t, comma, n minus 1, comma, true. After this, though, to calculate the right tail, this is just 1 minus the left. And then for two tail, this is just 2 times whichever one is lower, the left or the right. We'll still use the MIN formula and put the left and the right inside. So now let's calculate these. For big P on the left, we'll say t dist, click the test statistic, comma, n minus 1, comma, true. Now to calculate the right, we'll take 1 minus the left. And then to calculate the two tail, we'll take equals 2 multiply by whichever of the left or the right is lower. We say times MIN and select the left and the right. When we press enter, we'll get our two-tailed p-value. Now, since this test was indeed two-tail, the two-tail answer will be our p-value for this question. We'll paint it gold. Now step 6. Let's compare our big P against the alpha. Our big p-value is 0.00227. Our alpha was 0.01. We can tell from the numbers that the big P is definitely less than or equal to alpha. Therefore, we're going to go with the first option. The evidence is strong, therefore we can reject the null hypothesis and cross it out. This also crosses out the claim, and we are accepting the alternate hypothesis. So we can say there is strong enough evidence to reject the claim. Now, if we review the question, we'll see that the claim we are rejecting is that the diet has no effect. We have strong enough evidence to say that's false. For good measure, we'll also mention that this is at the level of 0.01 significance.